Question 8. W equals -1 plus I. Part I asks for the modulus and argument of W squared and W cubed, with full working. Part 2. W and W squared are the ends of a diameter of a circle. Find the equation in the form modulus Z minus A plus BI equals K. We begin with W itself, modulus and argument. Part 1. First find the modulus and argument of W itself. We need these before tackling W squared and W cubed. Split the screen into two columns. Left column, the modulus of W. Modulus x plus I y is the square root of x squared plus y squared. Here x is -1 and y is 1. Substitute, modulus west equals square root of 1 plus 1, which is root 2. Right column, the argument of W. On the Argand diagram to the left of the dotted line, W equals -1 plus I lies in the second quadrant, real part negative, imaginary part positive. The reference angle alpha comes from a right triangle with legs 1 and 1, arctan of 1 over 1 equals pi over 4. In the second quadrant, the argument measured from the positive real axis is pi minus alpha, pi minus pi over 4, which equals 3 pi over 4. On the right, alpha is arctan of 1, argument W equals 3 pi over 4. Summary, modulus W is root 2, argument W is 3 pi over 4. Finding W squared, we use direct expansion on the left and modulus argument rules on the right. Column divider. Method 1. Expand -1 plus I squared directly. Use the binomial square, 1 minus 2i minus 1 gives -2i. Expand step by step, W squared equals -2i. Method 2. Modulus argument rules. Modulus W to the n, argument n times argument W, adjust to the principal value. Modulus W squared is 2. Twice 3 pi over 4 is 3 pi over 2, subtract 2 pi to get -pi over 2. W squared is -2i, modulus 2, argument -pi over 2. Check, -2i lies on the negative imaginary axis, so argument -pi over 2. Finding W cubed as W squared times W, we already know W squared is -2i. Column divider. Method 1. Multiply W squared by W. Multiply -2i by -1 plus I, collect terms to get 2 plus 2i. Expand, W cubed equals 2 plus 2i. Method 2. Modulus argument rules again. Modulus is 2 root 2, argument 9 pi over 4 reduces to pi over 4. Modulus 2 root 2, argument pi over 4 after adjusting 9 pi over 4. W cubed is 2 plus 2i, modulus 2 root 2, argument pi over 4. Verify, 2 plus 2i is in the first quadrant, arctan 1 equals pi over 4. Argand diagram. Plot W, W squared, and W cubed. Each step is a rotation and scaling of the previous. Draw the Argand plane with real and imaginary axes. Plot the origin and the 3 points W, W squared, and W cubed. Label each point. Dashed radii from the origin to each point. Mark the argument of W, 3 pi over 4. Argument of W squared, -pi over 2 on the negative imaginary axis. Argument of W cubed, pi over 4 in the first quadrant. Moduli on the radii, root 2, 2, and 2 root 2. Each power multiplies the modulus by root 2 and adds 3 pi over 4 to the argument. Part 2. W and W squared are diameter endpoints of a circle. Find the equation modulus Z minus A plus BI equals K. The center is the midpoint of the diameter, W plus W squared, over 2. Step 1. Find the center. Substitute W and W squared, The center is -1/2 Box the center. Step 2. Radius k is half the diameter length. Modulus w minus w squared is √10, so k is √10/2. Radius equals half the diameter. Diameter length √10, radius k equals √10/2. Box the radius. Final answer. The circle equation, modulus z minus 1/2 equals √10/2. Argand diagram for part 2, the circle with diameter w and w squared. Draw the plane. Draw the circle with center C and radius k. Mark the center and the origin. Diameter endpoints w and w squared. The diameter has length √10. Radius k is √10/2. W cubed is shown for context, it does not lie on this circle. Thales theorem, an angle in a semicircle is a right angle, confirming w and w squared are true diameter endpoints. Center -1/2 radius √10/2. Full summary for question 8. W squared, w cubed, and the circle equation from part 2. That completes question 8.